Today we will discuss material balance on multiple units without reactive system. Just one of the practical example of daily life. As we know, seawater contains most of the salt which is going in the waste, and most of our objectives in industry and being a social workers is to clean that water and make it in drinkable form through evaporative method, multiple evaporative method, and evaporation process. So let's see how to do this by using different calculations in material balance. Let me explain this diagram according to our problems given in above. Here, this is a multiple effect evaporator. The objective with this diagram is to clean the seawater, which is going to be evaporated in multiple effect evaporators, and make it as drinking water and recover the brine from this clean water. The different lines, this line is showing your steam, which is going into your evaporator process, and this line is showing your vapors, which are going from above the evaporators like this. This is a vapors, this is water vapors, and these are the water vapors which are evaporating from the evaporators, which are going away from the evaporators. And this line is water feed. This is discharge line, feed line, which contains seawater having a lot of amount of salt, which we have to recover in this process, evaporation process. And at the end, this is our clean water, which is we are recovering this clean water at the bottom. And this is brine, which is the solid material recovering at the bottom of the evaporators, and we will continue to recover this until and continue to continue to treat this brine until it contains minimum moisture, or it will become 100% dry brine. So seawater containing 3.58% salt. In this diagram, seawater supply that contains 3.58% salt, and remaining remaining is water. It means that is 96.5% water, and passes through a series of 10 evaporators. This seawater is going to be passed in these evaporators, so that the water must be evaporated from this brine, and brine must be recovered at the bottom, and pure water should be recovered also at the bottom. Let's see. Roughly equal quantities of water are vapors in each of the 10 evaporators. Almost in all these 10 evaporators, same amount of water is evaporating, that is 0.1. If we have 10 evaporators, then the 10 divided by 10, it will be 0.1 fraction. And then condense and combine to obtain a product stream of fresh water. The brine, which is our concentrated solution of salt, leaving each evaporator, but 10th is fed to the next evaporator. Then the brine, which is we are recovering, as I have explained earlier, the brine obtaining from this, it may contain some moisture, so we have to treat this brine again and again in this evaporation process, so that we may get 100% dry brine, which contains even little moisture. The brine leaving the 10th evaporator contains 5.8% salt. The brine which is leaving the 10th evaporator, this is the 10th evaporator, let's suppose, it contains 8% of 5.8% salt. In the initial, it was 3.58% salt. Now the concentration of brine is increasing and the concentration of moisture is decreasing. Now the concentration of moisture has become 95%. This process is doing again and again, so that the maximum there must be a 99% salt having minimum amount of moisture, but the water recovered at the bottom should be maximum. Let's explain further. In the evaporation process, there are different effects: first effect evaporator, second effect evaporator, third effect evaporator, and fourth effect evaporator. In all these evaporators, water is evaporating from these brines, and the salt is recovering at the bottom, which is our brine. Now, if as I have explained that there are 10 evaporators, the moisture moving away, coming out from all these evaporators. If there are 10 units, then it will be if we divide fractions 10 into 10 equal parts, then it will become 0.1, 0.1, and 0.1 up to 10 times. So let's follow this in other side. So first we have draw a first and fourth and 10th evaporators diagram, in which we have put all the information known in the questions. Information known in the question are weight percent in the first, weight percent before the first evaporator, and the weight percentage of salt and water at the end of evaporators. So we have to determine the fractional yield. From the freshwater, fraction yield is your amount of water is recovered per amount of water processed in the feed, that is our salt feed water. So we have to determine the solution leaving the fourth evaporator. Then if we are talking about fourth evaporator, then it means we have to draw first evaporator and fourth evaporator, and at the end 10th evaporator. So the feed of the fourth evaporator should become it will be discharge of third evaporator, and the feed of 10th evaporator it will contains the discharge of 9th evaporator. So you have to clear these 2 points, that what feeds what products must be from first evaporator, what product must be from uh, fourth evaporator, and what feed and what product must be from 10th evaporator. Each equation you write should contain no more than one previously determined variables. So let's start from this. How we can, is it to process? No, it is just evaporator process. There is only physical change process. So there's no chemical reaction here. What must be the base in our calculations? You always have to take the basis of mass basis, because in the question you have given the information about the weight of solid. Salt is mostly salt is exists in the form of solid. So from where to start? This is the most important question. Many students get confused from where to start. So it's very simple. You have to take the basis of calculations, and you have to start from overall material balance, and then from component material balance, and at each evaporator we have to select the single unit material balance. Then you can determine easily all the unknowns variables. So what is the evaporator? Evaporation is just to concentrate your solution by removing water. What is vaporization? Vaporization is just to heat your material, and what is condensation? Condensation is you to reduce your temperature of the process steam. And what is the brine? Brine is your highly concentrated solution of salt in water. So we have selected the base of 100 kg. Why we have selected these bases? Because our feed contains salt. Salt is almost in the form of solid. So weight percentage is also given. So when we have known about the weight percentage, you can select the bases as a weight basis as a solid basis. So this is the block flow diagram, labeled flow diagram. So as I have mentioned, we have asked in the fourth evaporator we have discussed in the statement, and 10th evaporator and one first evaporator, but there must be a common understanding that the feed of the fourth evaporator will be the discharge of the third evaporator, and feed of 10th evaporator will be the discharge of 9th evaporator. It will contain, we have assumed that there are 10 evaporators. So if this information is given, that if we have one information, 1% of salt given, then other will be our water. We have selected based on 100 kg per hour, and these information fractions are unknown. Also, these information fractions are unknown. This information also given that if you see that the fraction in the water, seawater, the fraction of salt was less. No, the weight of solid has been increased, and the weight of water has been reduced, because the concentration of solute has been increased. So at the bottom, as I did, I have informed you that there are 10 evaporators, and you have to divide these evaporator fraction into 10 equal parts. Then this fraction will become with 0.1 multiplied by times your weight of water, and you can further solve it in the next section. So first, the very important question is that how to apply degree of freedom analysis, from where to start material balance. So when you apply the number of unknown variables and number of independent equations in the this system, you find that M10 is unknown and mass of water is unknown. And there are two material balances apply. You can apply salt material balance and water material balance. So degree of freedom analysis overall will be 0. This is your specified system. When you get this point, you can solve the material balance from this. Thank you.